This is the final lesson of Unit 4, Quadratic Functions, solving systems of equations. So far, we've looked at quadratic functions, we looked at linear functions. Now, what happens when you have these two combining a linear function and a quadratic function? Are you combining two linear functions, two straight lines, or you have two quadratic functions combining? What happens? So in this lesson, we're looking at solving systems of equations. It's where we have a set of two or more equations or functions. So an equation can consist of different types of functions. For example, a system can consist of linear equation, quadratic equation, or a mixture of both. And we're usually interested in where the equations of system interact or intersect with each other. What happened? Where do they meet? It's like you have two aircrafts, the path of two aircrafts in the air. You don't want them to collide, so you want to know the path they take, so they would not meet at the same time. So we use system of equations to figure out at what point these two planes will meet and to avoid those times. So we'll use our graphing calculator, or Desmos again, for graphing. So here in the first case, we only see the solved system of the equation. We're really finding out where these two equations or functions meet, where they intersect. So by finding where they intersect, we're finding the solution. So here we're given two equations. This is a quadratic equation, and this is a straight line. So you have a quadratic and a linear function. You want to find out now, where do they intersect? So I'll use the graphing calculator to show this first. So in the first stage, we would like to enter our equations into our calculator. So the first step, we enter these two equations into, in this case, be y1, and this would be y2 for the calculator. So y1 is equal to -2 x minus 3 squared plus 6, and y2 will be equal to minus 4x plus 15. Notice this is a linear or straight line, and this is a quadratic. Once we enter them into the equation, we will find out where they meet. So let's go ahead and find those. So the first one, we go to a y equal button, and I enter. Oops. There we go. So y is negative. Now, always remember to use your negative key rather than so we have a negative button way at the bottom here. Okay, maybe let's go a little bit, zoom out. So -2, open bracket, x minus 3, close bracket, squared, plus 6. That's line 1. And line 2, we have negative 4x plus 15. Next, I press graph. Now, notice you don't see anything. So we'll have to change our window, adjust our window setting, so we can see these two equations, or these two functions. To do that, I go to my window setting. Oh, there you are. Oh, what am I saying? Okay, the appear rather late. So I'll zoom in so you can see. As you can see from the graphing calculator, these two functions meet at two different points. So when you say solving system of equation, we're saying, what are these 2 points? Okay. So here we go. So make sure we got this equation, negative 2x minus 3 to the power 2, 6, and minus 4x plus 15. So we have our two equations. Press the graph, and both are here. Now I need to find where these two functions meet. So let's go to the first one. We press our second button, trace, and we want to go to intersect. Intersect, so I'll put this right down. So we'll have, sketch my graph here. Sorry about that, I'm gonna sketch it first, but at least I have an idea. So my graph is actually coming. So here's a quadratic. And here's a straight line. What I'm doing, I'm going to find these 2 points of intersection. So what you'll do now to find the intersecting point, to find intersecting point, press a second, maybe it's a trace button. Then we want to go to number 5, intersect. And enter 3 times. So let's try that. So second trace, you go to intersect. Now I need to find, it doesn't matter which one, I can go, now I need to put my cursor close to, see, negative 37, now I want to go up. Now notice my negative 37 means I'm way below the graph, or the window. So I need to go up. There it is. So I'm going to go slightly past it. Now I'm going to press enter 3 times. 1, 2, 3. That point now is 2.415.32. So that's your intersecting point. So that's your solution. So this first point here, all right, oops, I missed it. Second trace, go back to 5, intersect 2.4, 5.3. This is the first solution. Now the next one I need to find, which is, so you go like second trace, go to intersect. Now I want to go below the x-axis to close to the other intersecting point. Then I press enter 3 times. And that's 5.58, negative 7.32. So 5.6 approximately, negative 7.3. So those are the solutions. So the solutions are 2.4, 5.3. So that's where these two functions meet. And 5.6, negative 7.3. Okay. The next one, find the possible meeting points if one boat is traveling according to the equation y equals 6x plus 4. And the other one, the second boat is traveling with y is equal to 3x squared plus 2x minus 5. So we'll try to do a sketch in the corner here. So we enter y1 is equal to 6x plus 4, and y2 is equal to 3x squared plus 2x minus 5. And then we're going to go second trace. Five intersect. Into 3 times for each intersecting point, if there is any. Sometimes there isn't any. Well, let's see our graph here. We'll use Desmos in a minute. So we'll clear our graph. We're going to clear that one. Then we're going to go straight to our equation here. We're going to enter, oops, there we go, first one. Y equals 6x. 6x plus 4. And the next one is 3x squared plus 2x minus 5 in graph. No, this is a quadratic in red. And then we have the linear function in blue. We seem to have one intersection here. We don't know if there's another one because the graph is not, our window is very limited. So we need to increase our y value to our windows. And I'll make our y maybe 40. See what happens. So that's your linear function. And here comes your quadratic. And yes, it does intersect with these 2 points. So I'll do a sketch of that graph. So we're going to and then we have a straight line. So where these, oops, should be below it. Below here. Where these 2 lines, or these 2 functions intersect. It's what we refer to as a solution. And a good replication of this graph. So we need to put this up a bit higher. This is a bit lower. So we need to find where they meet. That's my sketch. So let's use the graphing calculator. So it would be second trace Number 5, intersect. And I'll move my cursor over. Press enter 3 times. And it meets at this first point, negative 1.1 and negative 3.1. So this point here, negative 1.1, negative 3.1. So that's the first intersecting point. The other intersecting point, I'll continue the same process, second trace, intersect. Now I want to go up, and then press enter 3 times. So it's 2.5219. So 2.5219.13. So those are your solutions. So our solutions are negative 1.1, negative 3.1, and 2.52, 19.3. In this other scenario, determine the potential crash points of 2 aircraft following their falling trajectories. So notice these are going to be 2 quadratic functions. Now, there can only be a solution if they do meet. If they don't meet, then there's no solution. Okay, let's see. Let's go to a Y button, and I'll enter the 2 equations or functions. So clear that, clear the second one, back to Y1. 3x squared plus 4. And the next one is 2 brackets. We have open bracket x minus 5, close bracket 1 minus x. So there are my 2 functions. Press graph. Here's the first graph. There's the second graph. So because it does not meet, there's no solution. So we can say this is y1 and y2 do not intersect. So there are no solutions. So when solving system of equations, mainly what you're doing, you're entering the equations into your calculator and find where they intersect. Okay. Now, for Desmos, it's as easy as you can get here. Right? You have to open up the Desmos. I'll let you look at the first one. Oops. In the first question, you're given these 2 equations. And for Desmos, you enter both of them. So we have, in the first case, we have negative 2, open bracket, x minus 3. X minus 3, close bracket squared. So we got that negative 2, x minus 3 plus 6. Okay, similar to what we had before. Okay, now we need to include our straight line, which is y is equal to negative 4x plus 15. Let's go to my next line here. y is my -4 x. Now, first of all, I need to find my y. Oops. Now, let's start all over again. Oh, not really. Yes, yes, yes. So we have our first one. The second one is y. Oh, come on. Y is equal to 4x. X plus 50. Forget my negative here. There it is. To find where they intersect. Oh, let's move it here. So I tap and tap. So 2.4, which is what we got here. 5.3, and then 5.51, 5.6 to 7.3. There are a couple of questions in your assignment, but I'd like you to try these questions here in assignment 3. So for these ones here, for number 4, the equations are all given. You're simply finding where they meet. The same as 5. So you want to complete question 1, 2, 3, 4. So I want to question the first 4 questions in your booklet on page 18. Okay, just going to try one to show you how it works in Desmos. Let's go to Desmos here. Look at the first one here. Here we have 2 system of equation. That's a quadratic, and this is a straight line. Now, I'll do it in Desmos, and then I'll come ahead and then I'll show you in the graphing calculator. So here we have 0.5 x squared. Oops, need to find my y here. Let's see here. So that's my equation. My second one, it's y equals -3 divided by 2. With Desmos, it's automatically put it in a fraction form if it's a fraction. X, not so in the graphing calculator, plus 7 divided by 2. My graph. Now, that graph should show up here. And there they are. To find where they intersect, I tap and tap. So those are my solution. My solution -5.4, 4.5, 1032, and positive 1.5 and 1.88. So that's finding system of equations. It's a matter of entering into your calculator the 2 equations and find where they meet. If they do not meet, we say they have no solutions. For example, the last one here is no solutions.